All right. Anybody have any questions on what we're doing so far? Anything on the homework?
Number 33, update 314.
314, 33? Yeah. That's the, okay. I'm going to go ahead and tell you that the way they do stuff sometimes, actually this one will make sense, but I want to talk about another one. So this just has you solving. And they're just uglying this up to try to intimidate you, okay? Now when you look at it, you see an x squared and you see an x. If you see that, you know it's a quadratic, okay? It's just an ugly a, b, and c value, or rather an ugly a and c value. So what is your a value? And your b, and your c. So just suck it up, be careful, plug it in there, and just trust the math. So if I'm solving for x, I've got negative b, or opposite of b, plus or minus square root of b squared minus 4 times the a value times the c value, all of that over the entire thing over twice the a value, right? So we're just plugging along. So my value of x is negative 5 plus or minus what ends up happening there. What is 4 times root 2 times 2 root 2? Yeah, because the root 2 and the 2 are, gives me 2, and the 2 times 2 gives me 4, and the 4 times 4 gives me 16. And what's 25 minus the 16? 9. And what's the square root of the 9? 3. So all of this ends up being negative 5 plus or minus 3 over 2 root 2. Now, that's 2 answers, and I can probably clean them up. So at this point, I'm going to rewrite that as negative 5 plus 3, which is negative 2 over the 2 root 2. And I'm going to clean that up in a second. But it could also be negative 5 minus 3, which is negative 8 over the 2 root 2. So yes, I can definitely cancel a 2 out, which gives me negative 1. But how do I rationalize that? So if I multiply the top and the bottom by root 2, I get negative root 2 over a regular 2. And then right here, I can definitely cancel that 2 and that negative 8 give me a negative 4. But how do I rationalize it?
The same thing.
Same thing. And that would give me negative 4 root 2 over what?
2.
Over regular 2. And then yes, I can cancel even further. And I end up with negative 2 root 2. And those would be my 2 x values that would make this true. So it's a little ugly, but whatever. What I did want to mention to you guys was we talked about equations that weren't technically quadratic equations, but that you could do them in quadratic form. Do you remember that? So for example, like if I had something like this, clearly that's a quadratic equation, right? You can see the x squared and the x. But I could also solve this, even though it's technically not a quadratic. If I FOIL all this out or multiply it all out, what's my highest power end up being? X to the 4th. X to the 4th is not a quadratic. But because it appears like a quadratic, and that a quadratic is a quadratic when you have a term, an expression that is being squared over here. And I have an expression that is being squared over here. So in this case, what algebra lets you do is make a little substitution, Like let A equal that just for a moment. And then it will look like a quadratic. You can go ahead and use your quadratic formula, but when I'm using the quadratic formula, here I would be saying A equals all that negative B plus or minus junk, right? So when you're done solving for A, what do you go back and do? You plug your A values back in here and solve for X. So like hypothetically, if this problem didn't have an X and an X squared, but instead had this and this there and there, I could still do this problem, couldn't I? But at the very end, I would go back and plug that X squared minus 1 over 3 in here, and I would solve this. And then I would set that equal to X squared minus 1 over 3, and I would solve that. You tracking with me? So make sure that you're comfortable with these. But don't make a problem harder than it needs to be. And what I mean by that is, here's an example. And I'm going to write it, and I'm going to tell you, do you guys see quadratic form here?
Yes. Yeah.
Technically, because my variable expression here, if I square it, shows up here.
Whoa.
Right? But don't you already know how to solve problems like this?
Yeah.
How would you normally solve it?
Root x equals and then or you can factor that.
You could, and you actually can factor this if you're creative, but didn't you learn that when you had square roots, you could just isolate, right? And then you could square both sides to get rid of the radical? Remember this? Like you learned that if I just left that here, moved that over, I could just square both sides to get rid of the square root. And then now I have a quadratic, right? And you can solve this way. So if you want to use a different method, use a different method. But if it shows up on this test, keep in mind that more than likely I'm wanting you to show those substitutions. Like say, all right, I'm going to let that be A, because that's technically, this right here is the same thing as root x squared. So if I wanted to, I could rewrite this as 2a squared minus 3a minus 1, and then use your quadratic formula. But I'm not going to make it wrong for you if you use something you already know. But just keep in mind, don't create new math. I see people that try to like come up with new ideas, which I love when you come up with a new idea that works. But if you come up with a new idea that's flawed, make sure maybe you run it by me. If your answers aren't matching, don't just assume it always works, because it very likely could get you in a bad spot. All right? Okay.
Can you do one more?
Yep.
Can you do 39 on that?
39
314.
with the W's and the I's.
Yeah.
Okay. All right, so 39 again says solve. So, what do you think they're trying to do here?
Solve. 1, 2. Cross multiply.
That's what I'm going to do. What do you think they're trying to do by making it look ugly? They're trying to get you to assume the position. We don't assume the position, right? So yeah, what would make it look a lot better is probably just cross multiplying and foiling. Cross multiplying, in case you don't know, is the same thing as multiplying both sides by a w plus 3i, which would cancel that. And then multiplying both sides by a w minus I, which would cancel that. And that's just, you can see that all that gave you was the same thing as this times this, and that times that. Okay? So I'm just doing the algebra here, and then to FOIL that, I get a 2w squared. Outside, first, outside gives me wi. Inside gives me positive 6iw or 6wi, whatever. I probably had to write wi. And then last times last gives me positive 3i squared, which is negative 3, because I squared is negative 1. So I'm just going to write negative 3. And then here, 3w squared, and tell me if you see me make a careless error, minus 3wi plus 4wi, and then minus 4i squared. But what's a minus 4i squared? Positive 4. And at this point, what would you do?
Probably
Looks better already, I think.
like
Move that left side.
Yeah,
Move the left side to the right because you kind of want to keep that w squared positive. I agree, so I'm going to subtract 2w squared from both sides. I'm going to take, this is what? 7wi, so I'm going to subtract 7wi from both sides. And then I'm going to add 3 to both sides. And that gives me, let's see, w squared. And this is what?
-6.
-6wi, and this is positive 7. Now, believe it or not, you could think of this as a factoring problem, but I'm guessing a lot of you are probably looking back and going, how do I factor it? The i's kind of messing with me. But technically, this is like a -7i squared. So you could kind of think of it as a factoring problem, but man, we're in the quadratic formula section, right? So let's use the quadratic formula. What is my a value if I'm doing the quadratic formula? 1. What is my b value? Be careful. -6i, right? That's my b value. And what's your c value? 7. So here we go. W is -b. So that gives me positive 6i, right? Plus or minus b squared. What happens when I square a -6i? Well, we'll figure that out in a second. -4 times the a, which is 1, times the c, which is a 7. All of it over 2 times the a. Now be careful. What is a -6i when you square it? It's, yeah, because you get a positive when you square it, a 36 when you square it, and an I squared when you square it. But what does that give me? -36. So I have 6i plus or minus -36 minus 28 over a 2. Again, all that is w. And what is -36 minus 28? -64. What's the square root of a -64?
8i.
8i. So all that becomes 6i plus or minus 8i over 2, which are what two things?
7i or
14i over 2, which is 7i, and -2i over 2, which is -i. And those are your two values of w. So again, not something that you see every day. Good little math team ciphering question if you were at a tournament and you were a cipher, or maybe even on a written test. But just don't be afraid of ugly values like radicals or i's in your a, b, and c term. Just stick with what you know and trust the math. All right? Okay. Hey, turn to your book. We've been talking about the quadratic formula and completing the square. Make sure that on your test, you know how to do both. After this test, I do not care how you solve. If I give you an equation and say solve and you want to factor it, knock yourself out. If you want to use completing the square to solve, knock yourself out. If you want to use quadratic formula and it's quadratic, knock yourself out. I don't care, but on this test, I am going to ask you to factor by completing the square. I'm going to ask you to solve using completing the square, and I'm going to ask you to solve using the quadratic formula. It might even be the same question, but I'm going to ask you to do both. So make sure on this test that you don't go, oh man, now that I've got quadratic formula, I don't need that completing the square thing. That might be true for solving, but we're not going to do that. We're going to know how to do both on this test. So just make sure, if you need any help on that, come see me after school or in the morning. I'm happy to help you. Okay, so turn to page where are we? Page 7. And we're going to start talking about quadratic functions. Okay, so quadratic functions are quadratic equations that have an x and a y. Okay, now if you think about most of the problems you've done so far didn't have a y, it had a 0. So you are finding the x values that made it 0. But when I throw a y in there, now it's a graphable equation. And quadratic functions, as you probably already know, graph as what? Parabolas. Now the behavior of that parabola can be all over the place. I can have parabolas that start up here in the first quadrant that go up or go down. I got quadratic equations that, quadratic functions that could be very wide in their nature or very skinny in their nature. So there's all kinds of behaviors that they have. And what we need to make sure you know, for whatever reason, is how they behave or what things make those behaviors are what they are. And there are two things that really control the behavior of a parabola, really three, but since we're talking about functions, we're only going to talk about parabolas that go up or down in this section. And then in the next section, when we talk about conic sections, and we look at ellipses and circles and parabolas and all that stuff, we'll talk about parabolas that go sideways. But parabolas that go sideways aren't functions, so you won't see those in this chapter, I don't think. Okay? So, I put a lot of notes up here, but bottom line is, when you're given a quadratic function, something in ax squared plus bx plus c form, there's not a whole lot about that that's going to help you graph it, unless you just want to plug in x's and get y's and plot points. But if I can magically change a function to this form right here, it's y minus k equals ax minus h squared, then I have two very valuable pieces of information. The first is I can quickly find the vertex. And you remember what the vertex of a parabola is? Vertex is that low spot right there if it's going up, or the high point if it's going down, okay? And that vertex we think of as kind of like the starting place of sketching a graph, all right? So that vertex, if I can get it in that form, I can find it pretty quickly. And then the a value, actually the a value here and the a value here are the same. The a value gives me a great insight into how the graph is, which direction it's opening. If a is positive, it always opens up. Well, unless the graph is going left or right, which it's not right now. The graph would be going up positive, it'd be going down negative. And if it's a big A, and when I say big, I mean bigger than 1. So if your A value is like 2 or 3 or 5 or 10, then the bigger it is, the skinnier it gets. And that could be skinnier going up or skinnier going down like that. And then the closer to 0 it gets, like 1/10, 1/20, 1/8, any of those values, the wider it gets. Okay? Now, when I say skinnier or wider, I'm kind of using like a regular basic old generic parabola as my frame of reference. So when the a value is 1, not a whole lot going on, it's just a basic little parabola. But anytime a value gets bigger, it gets skinnier. Anytime it gets closer to 0, it gets flatter. Y'all seeing that? So I'm going to talk about how exactly it behaves, and you're going to learn all this kind of stuff, and I've got a couple tricks I can show you. But we're going to need to be able to graph these, and we're also going to need to be able to go from here to here, and we're actually going to use that process that we had completing the square, and we're going to tweak it a little bit to make it look like this. Okay, so a couple little things first is, how do you find the vertex? Well, the vertex is that point at the very top, or perhaps the very bottom, and the way you can find it is look at what is being added or subtracted from x and y. And whatever's being subtracted, change the sign. I'm sorry, whatever's being subtracted is the number I use for the x coordinate. Whatever's being subtracted from y, I use as the y coordinate. But the easiest way to think about that is to go, if it's a -2, I'm subtracting a 2, so that coordinate would be +2 on x. If it's a -1, I'm subtracting 1, so the coordinate would be a +1 on y. But if I'm, see a plus here, I'm really subtracting what?
3.
I'm subtracting a -3. You see what I'm saying? You're subtracting a -3, and that's what gave the two negatives became a positive. So really the easiest thing to do is just see that number, change the sign, see that number, change the sign. See that number, change the sign, see that number, change the sign. Okay? And that will give you my vertex coordinate. And then I'm going to look at the a value. If the a value is negative, what is it doing? It's opening downward. If the a value is positive, it's opening upward. If the a value is 0, then it's not a parabola, so you don't have to worry about that. So it's either going to be positive or negative. And then because the a value right here is in between -1 and 1, which means it's closer to 0, you're going to see a wider looking parabola. It's a little bit wider in its opening. Here, the a value is not between -1 and 1, which means it's either greater than 1 or smaller than -1. Those get steeper or skinnier. You can see this thing getting skinnier and skinnier than normal. And I call a normal one is just when the a is 1. And you're not going to randomly sketch them like this. I'm going to show you some exacting things that you can do to actually find this. Are you good so far? Okay. So right here, can you tell me the direction it's going and what the vertex is and whether it would be wider or skinnier just based on this information? Start here. What's the vertex? -4, 2. Y'all see that? And since the a value is negative, it's going Down, and since it's
Skinny.
going to be a little skinnier than normal because it's bigger than or smaller than 1 or -1. Are you with me? What about this? Vertex?
Or -1.
4, -1. Direction? Down. A little bit wider than normal because it's small. It's in between -1 and 1. What about this? Vertex?
-4.
-4 what?
0.
0. So -4, 0. Which direction? Going up. A little skinnier, right? Because it's bigger than 1. What about this? I'm just messing with you at this point.
5/3.
Now, what the rule is what? Whatever I'm subtracting from x. Now, if you look back on the other 3, I'm subtracting or adding from x before I squared. So what have I subtracted from x before it was squared? Nothing. I mean, isn't that the same as this? What's x minus 0 quantity squared? X squared. So actually the x coordinate is 0. Now what is this? What's this going on?
It's -7.
That's me messing with you, right? That's just, it's not simplifying. If I subtract 5, there's my y minus 7. There's my x minus 0 squared. So when I see the x is squared, that just meant that there was, before that you had a shift on it, just means there's no shift. And you might have talked about shifts of the basic functions with Homer's last year. If you didn't, you might not have because last spring was kind of weird. But we'll go back over that stuff again this year too. So I'd have a nothing shift on the x, and then what? Up 7. So again, I was messing with you a little bit there, but whatever. And then what about this? So he said 2, -4. Why didn't I change the sign? Because what? That's right. So if I had moved that 4 over, it would have been y plus 4, right? And I would have changed the sign. So be careful. And by the way, your book does not write them like this very much because the book was made in 1980, and it's a good book, or 1980s. It's a good book, but back then people didn't have graphing calculators. And now that people have graphing calculators, they tend to write it in calculator-ready form. In your calculator, you always graph y equals. So books kind of changed in the early 90s to start writing functions like this. So I kind of do both, but make sure that if you see something like this, remember, this is a shift down 4. That's why you're down at -4. But if you were to write it in the other form we have, the y minus k form, that would have been a y plus 4. So remember to change your signs on that. Don't get tripped up. And then which direction? Down because it's negative, and then it's a fraction mean it's going to be really wide. Actually, that fraction's 1.5, right? So it's actually slightly a bit skinnier than a normal. Right? A little bit lean. Are y'all with me? Okay, so just make sure you can do that. And then also, I want to talk about a couple other things. Another thing that's sometimes helpful for us when we're graphing these parabolas is to know the intercepts. And the intercepts are where the graph crosses the x and the y, right? Now tell me something. If I have a parabola like this, right? I'm just giving you a random one. And it look like this. What do I know about that point? I know something about it. What do I know about it?
Positive.
The what?
It's the y-intercept.
It's the y-intercept. So what do I know about one of the coordinates?
0.
What?
Or y, x.
Clearly the x-coordinate was 0, right? So if I'm looking for a y-intercept, I can always plug a 0 in for the x. And if I plug a 0 in for the x, would I be able to solve for y?
Yep.
Great. And if I want to know x-intercepts, what do you know about both of those points? The y value is 0. So if I ever want to find the x-intercepts, all I got to do is plug a 0 in for the y and solve for x, which is a little trickier. Takes a little bit more, but we can do it. So let's check that out. What if I want to find the intercepts of all of these? Help me out. Let's find the y-intercept first. So to find the y-intercept, what do? 0 for x, but that's not going to be a problem at all. Y minus 2, plugging a 0 in there gives me 4 squared. What do I have here? 16 times 3,
48.
negative 48. And then you'd have to do what?
Plus 2.
Add a 2 over, gives me negative 46. So the intercept, the y-intercept would be when x is 0, the y is negative 46. That would be the actual point of the y-intercept, right? Now, how do I find the x-intercept? Plug in a 0 for y. Now, when I plug a 0 for y in, I initially get this, right? Y'all tracking with me? Here's where people make their life really difficult. Somebody give me an idea what you would do to solve this. There's two general ideas, and neither of them are wrong, but one of them is going to be harder than the other. Okay, one option is to divide by -3. Then what? Now, if I FOIL it right now, here's what's going to probably happen. If you go ahead and multiply that out, you're going to get x squared plus 8x plus 16. And then to solve this, what would I have to do? I'd have to bring over the 2/3, which now I have a bigger mess, right? Subtract 2/3, so now I got 15 1/3, which is what, 46 thirds? And then what would you have to do? Either plug that a, b, c into the quadratic formula, or multiply through by 3 and plug that a, b, c in the quadratic. It's getting uglier by the moment, isn't it? So my advice to you is you don't do this. My advice to you is right here, don't you have a nice completed square? What else could I do? Square root both sides. So right here, just square root both sides. And what does that give me on the right side? Technically absolute value. So what do I have to put on the left to take care of that absolute value? Plus or minus. Can I leave it as the square root of 2/3?
No.
I'd have to rationalize, right? So root 3 over root 3 would give me root 6 over 3. And then what would be the last step to find the x value? So subtract 4. So I get -4 plus or minus root 6 over 3. What does that mean if that's an x-intercept? That my points are what? That's an x-coordinate, right? Actually, it's two x-coordinates. It's -4 plus root 6 over 3, comma 0, and it's -4 minus root 6 over 3, comma 0. And both of those are fine. And also, for those of you who are thinking, do I need to add this together? It probably, in the back of the book, they're probably going to find a common denominator by putting a 3 on the bottom and a 3 on the top. And they're probably going to write this as -12 plus or minus root 6, the whole thing over 3. I may be wrong, but honestly, I don't need for you to do that. I think I mentioned it's better to do that in one of the videos. When do you not add these two terms together? I mentioned that. When there's an I in there. When there's an I in there, I want to have that a plus bi form. So if this happened to have an I, like if that happened to be negative there and you pulled an I out, then don't try to add these two together. You want to write it as a plus or minus bi form. And those would be your x-intercepts. And sometimes it's not this much math, sometimes it is. Now, on this situation, this is a quadratic function. You can't look up here and tell what the vertex is, can you? Can you tell which direction it's going? Yes, because that a value is the same as the a value. But the b and the c don't mean h and k. So I do know that it's going up, okay? And I do know that it's a little skinnier than normal, but I don't know where anything else is. But I don't need to know that because I just want intercepts. So how do I find, say, the y-intercept? This is super easy.
0 equals
So 0 for x gives me what?
1.
1. Yeah, I get y equals 0 minus 0 plus 1. I get y equals 1. So great. Super easy y-intercept. But how am I going to find the x-intercept in this case? The x-intercepts.
Solve for
0
0.
for y. And I'm going to have to pull out my quadratic formula on it. Unless it factors. This one actually does factor. So if you get lucky, 2x minus 1, x minus 1. So you get x equals a half, x equal 1. So your points are 1/2, 0, 1, 0. So if you get lucky and it happens to factor, awesome. If it doesn't, pull out your quadratic formula again. You seeing that? And then again, this thing and this thing are very similar, but the reason why I gave you this one is I wanted to show you what happens. Remember, the directions are to find the intercepts. So I want you to answer this correctly, not just do the math and just quit. So think the whole time. How do I find a y-intercept again?
Plug in 0 for the
If I plug a 0 for x in there, what do I get?
-3.
-3 squared is 9. 9 times negative 2 is negative 18. So y is negative 19. Great. Now, here's where it gets a little tricky. X-intercepts. X-intercepts, what do I do? Plug in 0 for y. Check it out. What would you do first? Divide by negative 2. What would you do second? What happens when you square root that negative? Okay, so let's start thinking about that. Not only do I get plus or minus, and I get an I, and the square root of 1/2 rationalizes to root 2 over 2. So I'm going to write that, although I don't have to, because right here, what does that mean? Can I have an x-intercept that is imaginary? So what does that mean? It doesn't exist. So if I ever get an imaginary value of x, that means that this graph didn't have any x-intercepts. Is that possible? Yeah. Parabolas? Look at, where's this parabola? Where does it begin? Where's the vertex?
3, -1.
Here's 3, -1. Over 3, down -1. Which way is this graph going? Down. So if I have a 3, -1 going down, I'm not going to have any x-intercepts. So what I'm trying to tell you is, don't on a test, when I ask you for x-intercepts, say, oh, the x-intercept is 3 plus or minus I root 2 over 2, comma 0. Don't tell me that, because there aren't any. Don't give me the imaginary value that gives you a root there. Say none. There are no. If I ask you for that, there aren't any. Are y'all seeing that? So make sure you differentiate that question. I do that every year. I ask, and every year people do all this math. The second you see that it's a square root of a negative and you get an I, there are no. There might be roots. There are imaginary roots, but x-intercepts are actual places where it crosses the x-axis. This does not cross there. Y'all with me? Okay, scrolling on. Axis of symmetry. Do y'all remember what the axis of symmetry is?
Like the line down the middle.
Yeah, it's the line that runs right down the middle of a parabola and kind of makes the reflection on the left and the right the same. It is arguably the most worthless statistic that we have, that we don't really ever use solving equations. Sometimes we might use it to sketch the graph. If I know a point over here, I can pull it over there to create that symmetry. But I want to show you a little shortcut. If you want to, you can always go and graph it, right? You can go and graph it and find that and go, oh, look at that. It ended up being wherever that value is, right there. I was over 3 before I went down. Where am I? Oh, I lost it. Before I went down a little bit. So that would be an x equal 3 equation. You can do it that way, but let me show you a little shortcut. The axis of symmetry, it's really easy to remember this, and it beats having to sketch the graph. If you just take what you're squaring and set it equal to 0 and solve, that's your line of your axis of symmetry. So if I take that and set it equal to 0, I get x equals -4. Literally, the vertical line, x equals -4, that's my axis of symmetry. Saves me the trouble of thinking. Right here, x equals 2. That's my axis of symmetry. Here, x equals -7. Just makes it really easy and you don't have to deal with the sketching of it. But if you want to graph it and look at it, whatever, great. And by the way, when we get next chapter, when we get into conic sections and we have sideways graphs, then the x stuff will be over here and the y stuff will be over here. You can still grab the part that's being squared, set it equal to 0 and solve, and it'll give you your axis of symmetry. So it works both for parabolas going up and down and for ones that go left to right. All right? Still pretty good? All right? Okay, graphing them. Okay, I'm going to get a little bit ahead of myself, and I'm going to teach you something that you're going to learn in conic sections, but I think it makes your life easy in the long run. But you're going to have to trust me on some of these values. It's going to make your life, really, you're already going to know a lot of the material for next chapter based on this. But over the years, I've not done it, and then I've shown you this, and I think in the long run, people are better off me showing this. Now, I don't know, have y'all ever studied parabolas before?
Yes.
Did you get into the graphs, and does the word lattice rectum or C value, does that mean anything to you? Yeah, I know, lattice rectum, if you take Latin, that means like wide, opening, whatever. It kind of means the same thing here, okay? We're going to use a concept called the lattice rectum, which actually shows up in all the conic sections, although specifically in this one for what we're doing. The lattice rectum is the width, hence lattice, in Latin means wide or width, and then rectum, which means opening, okay? So the width of the opening at a very particular point called the focus. Okay, now we're going to talk about the focus a lot next chapter, okay? But if I can determine the width at the focus, then I know how wide this thing is. If the width is really small at the focus, maybe it's really skinny. If the width is really wide at the focus, maybe it's really wide, okay? Now, it just so happens that that lattice rectum, that length right there, the lattice rectum is the segment. So we're going to be looking at the length of it. The length of the lattice rectum just so happens to be the reciprocal of A. Always. So if you know your A value, flip it, that's your length of your lattice rectum. So the real question is, that's easy to find. So if I gave you an equation like this, y minus 2 equals 1/10 x plus 1 squared, I can go, well, A is 1/10, so what is the length of my lattice rectum? 10. So I immediately know the width. The problem is, I don't know where the focus is yet. And the focus is where that width occurs. I just can't draw a 10 randomly and say go through, because I could draw if the vertex is right here, I could draw that 10 all kinds of places, couldn't I? So the focus, it turns out, is a separate point that happens to be what we call C, away from the vertex. Now, C, it turns out, is always 1/4 of the lattice rectum. Always. So to find that C, and by the way, if you're wondering why in my notes I put absolute value for lattice rectum, if the length of the lattice rectum is a length, lengths are always positive. So I'm always going to take the absolute value of it, okay? Now, if the C value on this problem is 1/4 of the lattice rectum, what does that make the C value here? 2.5. So I would now have the actual length here, which is 2.5. Now, this is a different problem. I'll do this problem in a second. I would have the lattice rectum, which in this case is 10, and I could go and mark this. And how would I know whether to go up or down? It would depend on whether the A value was positive or negative. So if it was positive, you go up 2.5 over a total of 10, mark those 2 points, and you'd have a width. You could sketch it. If it was negative, you go down 2.5 over a total of 10 and sketch it through those 2 points. You with me? So, for instance, if I gave you these 3 problems, let's just walk through them. What do you do on this number 1? Tell me what you know real quickly. The what? Length of the lattice rectum is, the A is 1/16, so the lattice rectum is the reciprocal of that, right? So the lattice rectum, the length of it is 16. And then how would I determine the C value? It's 1/4 of that lattice rectum, so it's 4. And what's the vertex?
-1.
-1, 2. And I can mark that. Here we go. -1 up 2. Now, how do I find the focus? We said the focus was how far away from the vertex? C. And which way am I going on this problem? Up. So go up C. Up 4. 1, 2, 3, 4. There's my focus. So it turns out my focus is what? -1, 6. And I got that because I added 4, right? Added C. And now how do I sketch my parabola? Well, the lattice rectum is the width of the parabola at the focus. So your width is what?
6.
So if there's my focus, what do I need to do?
8 each way.
8 each way. So I'm going to go 8 that way. 1, 2, 3, 4, 5, 6, 7, 8 that way. And that gives me 2 points. And I can just kind of eyeball the sketch at that point. And I realize we all have differing degrees of ability to sketch. Some of you guys are artistically impaired. That is okay. Do the best you can, but make sure that I see these 2 points there on either side of the focus. Y'all tracking with me? Now that's a great way to sketch when your A value is close to 0, like a smaller fraction. Let me do it a couple more times, and then we'll talk about what happens when your A value is not that. And I don't know if I'm going to finish, so I'm going to jump to, we'll just do number 2. So number 2, what's the lattice rectum of this thing? Flip it, it's positive 8. Now remember, we make it positive because it's a length. What would the C value be? A fourth of that would be 2. And then what would the vertex of this one be? 2, -5. Now my focus, I'm going to go ahead and mark 2, -5 here. There's my vertex right there. My focus, is it going to be up or down? Why? Because the A value is negative. So I'm going to go down, how much? 2. So that gives me the point 2, -7. So I basically subtracted 2 and got 2, -7. And then what do I do now that I have my focus to sketch this? What do? I go a total of 8, so 4 each way at the focus. So 1, 2, 3, 4 that way, 1, 2, 3, 4 that way, and I've got 2 points. That's good enough for me to sketch this thing. Not too bad? We good? So that's what you're going to do when the A value is a fraction. Now when the A value is not a fraction, when it's something like 3, -4, 2, toss this out the window. Because let me show you how bad an idea it is this way, but then I'll show you a really good way right here. So just walk with me how bad this would be using the lattice rectum. Okay, what's the length of my lattice rectum? Oh, great, 1/3. What's my C value? 1/4 of that, which is 1/12. What's my vertex? -1, 2. Which way am I going? Up? Okay, here's what I would do then. I'm going to go up 1/12. All right, here we go. Okay, now I'm going to do what? Sketch my lattice rectum, which is a total of 1/3. So that's 1/6 each way. Here we go. Okay, sketch your parabola. So you don't know jack. And that's what it's going to be like when your A value is not a small fraction and you get bigger lattice rectum. But this is how easy it is if you have an A value. I call this my cheap trick because it is actually really cheap. And who doesn't like the 70s rock band Cheap Trick, right? Probably a lot of them. Anyway, so some of you do. Good. So right here, if your A value is not a fraction like an 1/8 or a 1/12 or a 20th, just take that number and treat it like slope, but just one time. So you know you're going up, right? So I'm going to go, I'm sorry, it's kind of like slope. I'm going to take that A value and put it over 1. So I'm going to go up 3, up the A value, over 1. And since it's axis of symmetry, I can go over 1 each way. Now, don't do this again. If you do up 3 over 1, up 3 over 1, up 3 over 1, then you end up getting a V function, don't you? That's a line. It only works once, but all I need is 2 points, right? So I got 2 points. I'm going to sketch my parabola. Good enough for me. Try it here. What's my vertex?
2, -5.
2, -5, over 2, down to -5. What's my lattice rectum? Oh crap, 1/4. What's my C value? Crap, 1/16. That's not helpful. So what do? I take the A value, I put it over 1, and I treat it like slope. So what would you do here? From there, down 4 over 1. Because of the axis of symmetry, I can go either way, right? Sketch your graph. Lastly, oh, and by the way, if you're wondering, why don't I do this on the other problems? Well, check it out. Look at this one. How much help would it be if I went -7, 0, and then I went, oh, I'm going to take the A value and treat it like slope. Okay, go up 1/10 over 1. Doesn't really help me, does it? So use the lattice rectum on problems that you have fractions like that, and use the cheap trick on the other ones. And I think that covers it. Your homework is this part 1 worksheet. You can knock all that out. You're in great shape. If not, bring me your questions tomorrow, and we'll get you in great shape. All right?